All right, let's get right into it. We've been building a machine learning model to predict pumpkin prices, and well, the results haven't been amazing. Today, we're going to fix that. We're going to unlock a really powerful technique that will make our model a whole lot smarter. So, remember our first attempt? We tried to predict the price of pumpkins using just one single piece of information, the day of the year. And frankly, the model was terrible. It just couldn't figure out what was really driving the prices. So, what was the missing ingredient? In machine learning, when your model isn't working, 9 times out of 10, the answer is pretty simple. You need to give it more context. If we add more information, more features, we're probably going to get much better predictions. A single data point almost never tells the whole story. Now here's where things get really interesting. We have some great new data we can use, the pumpkin variety. I mean, this just makes sense, right? A tiny miniature pumpkin is obviously not going to cost the same as a giant fairy tale pumpkin. But here's the catch. This data is text. It's words, not numbers. And that brings us to the real puzzle here. Our regression models, well, they're basically math nerds. They live and breathe numbers. You can't just feed them the words fairy tale and expect them to know what to do. So how do we translate these really important categories into a language the model can actually understand? Well, the first thing everyone tries is to just assign a number. Let's make fairy tale a 1, miniature a 2, and so on. But whoa, hold on. That's a huge trap. Doing that creates a false ranking. The model might start to think that miniature, which is number 2, is somehow twice as important as fairy tale, which is number 1. And that's just complete nonsense. We need a way to show they're different without accidentally ranking them. And this leads us right to the breakthrough solution. We need to handle this data properly by treating it as what it is, a categorical feature. This is the absolute key to unlocking all that valuable information hidden in our text data. So what exactly is a categorical feature? It's really simple. It's just a variable that holds labels instead of numbers. Think of it like putting data into different buckets or groups, like fairy tale or pie type. The point isn't to measure how much of something there is, but just to classify it. The specific tool we use to pull this off is called one-hot encoding. Now that sounds super technical, but I promise, the idea behind it is brilliant and simple. We take our one variety column and we blow it up, creating a brand new column for every single category. Then we just use a 1 or 0 as an on-off switch. And check this out. This shows you exactly how it works. See? A pumpkin that was originally labeled pie type now gets a 1 in the new is_pie column and a 0 in all the others. A fairy tale gets a 1 in its column and zeros everywhere else. And just like that, we've turned our text into numbers our model can use without creating any of those fake rankings. It's pretty genius. Okay, so now we have this amazing new feature. We're done, right? Let's run the model. Well, not so fast. If we try to train our model using only this new categorical feature, the results are still not great. And this just hammers home that first lesson. A single feature, no matter how clever it is almost never enough. The real magic happens when you start combining things. We need to build the full picture for our model. So we add in the month, the city where the pumpkin was sold, the package type, and our new one-hot encoded variety. By putting all of these together, we're giving the model a rich, complete view of the data. Okay, so with this winning combination of features, it is time to rerun our models and see if all this work actually paid off. This is where we go from a model that was basically useless to one that's a prediction powerhouse. And here are the results. Using a standard linear regression model with all those features, our mean error just plummets down to only 10.6%. That's a massive, massive improvement. We've gone from being totally lost to being pretty darn accurate. And to really back that up, we can look at something called the coefficient of determination. Think of it like a report card for our model on a scale from 0 to 1. Where our first model was basically just guessing, this new one gets a score of 0.94. That's a solid A. It means our model can explain 94% of the price changes. Look, a 94% fit is fantastic. We could absolutely stop here and call it a day. But, we're always asking, can we push it just a little bit further? What if we try a slightly more complex model on this same amazing dataset? And would you look at that? By switching to what's called a polynomial regression model, our mean squared error drops even further. We are now down to just 8.9%. That is even more accurate. And our report card score gets another little boost too. all the way up to 0.96. This is a really, really good result. At this point, we can be confident that our model can make solid, reliable predictions about pumpkin prices. Super cool. So let's just take a breath and think about what we've learned. We've gone on a whole journey here, from a totally failing model to a highly successful one. So let's boil this whole process down into a simple workflow that you can use on your own projects. Here it is, in just 4 steps. First, you identify that your model just isn't performing well. Second, you add more relevant data, more features. Third, and this was the big takeaway from today, you make sure you convert your non-numeric categories the right way, using something like one-hot encoding. And finally, you combine all your features, test your results, and iterate until you get the performance you want. So think about what we've accomplished. We've successfully used categorical data to help us predict a number, the price. But this opens up a really fascinating new question. What if your goal is to predict the category itself? Like, what if you wanted to predict whether a pumpkin is a pie type or a fairy tale based on its other features? Now, that is a whole different type of problem, and it's exactly where we're heading next.